Hello, I'm Ian from crackmaths and welcome to this tutorial on prime numbers. If you are following along in the Everything You Need to Know for GCSE series, this is tutorial 78, which can be also found on the crackmaths website. Okay, so this tutorial is focusing on prime numbers. So on the screen you'll see 4 different types of questions involving prime numbers. If you feel confident with these already, then that is great. You can stop the video here, and that is wonderful. Maybe go have a go at the practice questions on this. Otherwise, stick with me and everything will become clear. Okay, so let's get started. The first thing that we need to do with prime numbers is work out, well, first of all, find out what they are, and then think about how we find them. So prime numbers are numbers which have exactly 2 factors. Okay, this is very key. If a number has more than 2 factors, it's not prime. If a number has less than 2 factors, it's also not prime. So exactly 2 factors is what a prime number has. Very explicitly, first thing to note, 1 is not a prime number. We need to remember this. This comes up a lot and it's often there to trick us, but 1 is not a prime number because 1 only has 1 factor, which is 1. Because 1 is made by 1 times 1, and that is that. Okay, right. Okay, so one of the main ways that people have for finding out the prime numbers, which we need to know, which in the GCSE Maths is all of the prime numbers up to 100, is this device which is called the sieve of Eratosthenes. So Eratosthenes is the Greek mathematician that came up with this idea. And what we basically do is we go through it and we cross off all of our times tables except for the first number in each times table, because that could be a prime number. As we go through this, what is left is the prime numbers. So the first thing we need to do is cross off 1, and then I'm going to circle 2, okay? And we're going to focus on the 2 times table. So what I'm going to do is I'm going to highlight everything that's in the 2 times table, because all of these numbers are not prime numbers. So these are numbers that I'm disregarding, okay? So the way this is going to work is the sieve will eventually reveal a collection of numbers to us that are not in any times tables, and those numbers will be our prime numbers. So here we go, we can get rid of these quite quickly. So that is all of the even numbers gone except for number 2. So the next thing I need is I'm going to circle my number 3 here, and now I'm going to highlight everything in the 3 times table because they are not prime numbers, because if something's in the 3 times table it is divisible by 3, so therefore it's going to have more than 2 factors, because remember every number has 2 factors, 1 times itself, so whenever that number then appears in someone else's times table it is going to be not a prime number because that is going to give it an additional factor. Okay, so 3, so goodbye 6, goodbye 9, goodbye 12. Okay, there we go. That's all the number 3's gone. So next one, we've got 5. The 5 times table is nice and easy because it's all in this one column. So I'm going to just do it like this here. So goodbye to all of these ones in this column, and goodbye to everything in the tens column, but everything in the tens column is already gone because they're all even numbers. Next, we've got the 7 times table. Whew, okay, so the 7 times table is a bit harder. So we've got 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, and 91. Here we go. Right, 11 times table. Well, 11's nice and easy. It looks like we've already got rid of all the 11s. 11 is just this diagonal here. 11, 22, 33, 44, 55, 66, 77, 88, 89, 99. So that's fine. 13s, let's see. So we've got 13, 26, 39, 52, 65, 78, 91. Okay, the 13s, nothing there. Let's try the 17s. 17, 34, 51, 68, 78, 85. Well, the next one will be even. Nope. There we go. I think what we're finding actually now is we've probably almost done enough to cover everything. So let's do the 19. So 19, then we've got 38. 38, then we'd have 57. 57, add 10 is 67, add 9 is 76. Add 10 is 86, add the 9 is 95. Okay, so that's fine. 23, is there a 23 times table thing going on here? So we've got 23, and then that would be 46, that would be 69, that would be 89, 92. Yeah, well, 29 times 3 already takes us up to, well, let's do 29 as well. 29, 58. 58 plus 20 is 78, plus 9 is 87. 31, we have got 31, and then we'll have 62, and then we've got 62, we've got 93, that's already gone as well. 37 here, 37 would be 74, which is there, and then add another 30, we're gone there. So 41, 82, 43 goes to 86 next, 47 goes to 94, that's not prime, and then 53, none of these numbers are going to have numbers in their times table that is less than 100. So here we go. I'm just going to highlight the rest of these numbers, and these are our prime numbers, okay? So let's make a note of these. You are never going to find anything that you can divide these numbers by, okay? That is the situation is, these are the prime numbers under 100. So let's write them down. We've got 2, 3, 5, 7, 11, 13, 17, 19. Okay, right. And so that's that for identifying the prime numbers. Okay, so here we go. These are the prime numbers. Now, remember, all of these numbers can only be made by doing 1 times themselves, okay? So none of these numbers have any factors other than 1 and themselves. So let's have a look at what that means. Well, number 1, it means cannot be arranged in a rectangle. Let's have a look at this with one of the smaller prime numbers. Let's take 7. So if I have 7, I can make a rectangle with 7 squares in it by doing 1 times 7. 1, 7. But that is going to be the only way I can make a rectangle with 7 squares in it. If I try to do it any other ways, let's try it this way here. So 1 square, 2 square, like this. It won't work. If I tried to do it 3 here and 3 here, that won't work either. So the only way you can arrange prime numbers as a rectangle is in their original form here. So as their 1 by their 7, okay, or their 1 by their 13, or their 1 by their 73. There is no other way to arrange these numbers. So that is the first thing. They cannot be arranged in a rectangle. 2, they cannot be divided into equal groups. Okay, let's say we've got a different prime number this time. Let's say we have got 13. So let's say we've got 13 things here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's not going to be any way that you can group these things equally. There's always going to be one unequal group. So that is another key thing to remember about prime numbers. So 1, they cannot be arranged in a rectangle. 2, they cannot be divided into equal groups. 3, remember, there is only one even prime number. So right, the next type of thing we might be asked to do is, along with knowing what the prime numbers are, is testing if a number is prime. So let's have a look at how that works. How do we check if a number is prime? 1, is it even? If it's even numbers are not prime unless it is 2. Number 2, do its digits add up to a multiple of 3? Okay, if its digits add up to a multiple of 3, then it is not prime because it is divisible by 3. 3, does it end in a 5? If it ends in a 5, it is not a prime number. These are a few divisibility checks that we have that we can carry out to find out if the number is prime or if it's not prime. Now, obviously, we don't have a divisibility check for every single number, but once we've gone through these, we can then begin to have a look at doing some calculations. So let's take a look at a number that looks like it could be prime. So let's check out 107. Is 107 a prime number? Well, let's start by checking out what it can be divided by. So 107 divided by 2, 107 divided by 3, 107 divided by... Once we've done divide by 2, we don't need to do divide by 4 because basically this is kind of like, what we're doing is we're looking for the first state of proof. So we don't necessarily have to go. So, but I'm going to write here 5, 107 divided by 7, 107 divided by 11. Right, let's try these numbers to start off with and see if this is something that we can do. So here we go. 107 divided by 2. There we go. 53.5. Okay. 107 divided by 3. 35.6. Okay. So 107 divided by 5. We know it can't be done because it doesn't end in a 5. 21.4. 107 divided by 7. That's 15.2. So no. Now we've got here 107 divided by 11. 9.72. Right, and now, because our answer number here, 9.72 for this last one, is smaller than the number we were dividing by, we can actually stop, because we know that there's no point in increasing the number we're dividing by, because the answer is just going to get smaller and smaller and smaller, and we've already checked out all of the options for the numbers less than 11 anyway. So we know now, if we've got to this point, that 107 is a prime number because it's not divisible by any of the prime numbers up to 11, and when we do divide it by 11, we get an answer smaller than 11, so therefore if we continued, there would be no point because we'd be looking at 13, which should give us a number close to 7. We'd look at 17, which should probably give us a number closer to 5, and so on like that. So there's no point continuing on. We know now that there are no whole numbers that 107 can be divided by. So is 107 prime? Yes. Let's try another example of that. So let's pick another number. This time, let's try 171. So straight away, I actually can see that 171 is going to be not prime because it's going to be divisible by 3, because 1 add 7 add 1 equals 9, and 9 is divisible by 3. But let's show our working for proving this. So first of all, we're going to do 171 divided by 2. Okay, we know that that's going to give us a decimal answer because 171 isn't even, but let's do that anyway. 171 divided by 2. Here we go, 85.5. So now let's try 171 divided by 3. So 171 divided by 3, and that equals 57, and there we go. So because we've already found that, we can conclude already not prime. So is 171 prime? It's not prime. And why? Because 3 times 57 equals 171. There we go. It's not a complicated proof. It's just stating once you've found the solution that proves it's not prime, you can just stop. So there we go. Right. The next part, we're just looking at the implications of a prime number. So we sort of covered this already. So the implications of a prime number are, 1 is it can't be split into equal groups, which we sort of covered, and number 2 is its lowest common multiple will be itself multiplied by another number. Okay, and I guess number 3 is the really obvious one, is that it can't be divided by a whole number other than itself. Okay, so here we go, we've got 3 key implications there. 1, it can't be split into groups. 2, its lowest common multiple will be itself multiplied by the other number, and number 3, it can't be divided by a whole number other than itself. Okay, let's have a look at some questions. So example 1 here says, circle all the prime numbers in the list. So hopefully you might remember some of these, but we've got 17 is definitely a prime. 18 can be divided by 3, so it's not a prime. 19 is a prime number. 21 can be divided by 3, so isn't prime. 23 is a prime number, and 25 can be divided by 5, so it is not a prime number. Let's have a look at the next one. So here we go, example 2. Example 2 says, the number 87 looks prime, show why it isn't. Okay, so first of all, let's do 87 divided by 2 to show that it isn't divisible by 2, and that's going to give 43.5. And now let's try 87 divided by 3. Okay, well 87 divided by 3, let's get the calculator out for this to see what that's going to be. 87 divided by 3 will be 29. So there we go, 87 divided by 3 equals 29. And therefore that's proven it, but we could also write 3 times 29 equals 87, so not prime. Okay, let's look at example 3. Example 3 says, a fruit seller has 61 apples and wants to pack them into equal bags with no apples left over. Show why each bag must contain 1 apple or 61 apples. Well, in other words, they're asking us to show that it's prime. So let's do the same thing again. 61 divided by 2 equals 30.5. 61 divided by 3, well, let's find out what that is. 61 divided by 3 is 20.3 recurring. 61 divided by 5 will equal the next thing, because there's no point dividing it by 4 if it can't be divided by 2. So 61 divided by 5 equals 12.2. Remember, we're looking for this number to become smaller than this number, and then we can stop. 61 divided by 7, 8.7. And then we've got 61 divided by 11, 5.45. So there we go. We have now shown why each bag must contain 1 apple or 61 apples, because there is no way of dividing 61 by any whole number, so therefore it is prime. 61 is a prime number. We can state that as well, but we've also shown it here with our things. There we go. Sorry about that. 61 is a prime number. So here we go here, our last question, example 4. And this says, a cinema has 13 seats in a row. The manager wants to split the row into equal sections of seats. Explain why this cannot be done. And again, this is 13 as a prime number, and we can just prove it by using our dividing techniques. So 13 divided by 2 is 6.5. 13 divided by 3 is going to be, well, it's going to be 12. 12 divided by 3 is 4, and it will be 1/3 left over. 13 divided by 5, well, that's going to go in twice with 3/5 left over. Because this number here is now smaller than this number here, that means we have shown all the possibilities of how to potentially make 13 from numbers, and that's that. Right, okay, thank you very much for sticking with me through that tutorial on prime numbers. If you need more help with that, well, if you want more practice with that, there are questions on the website. And remember, this was tutorial 78, and that was about prime numbers. Okay, great. See you later. Bye.